Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and/or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Hi everyone, and thank you for joining us for the Partner Talk, which is proudly brought to you by the Oxygen Alliance. My name is Emmanuel Shawia, and I am hosting the call from Lilongwe, Malawi. And I would like to welcome each and every one of you, and thank you for joining us in today's call. I would like to know where you're joining us from, so just type your location in the chat, and also we do send out email reminders. So if you want to stay in touch with us, you can as well just type your emails in the chat. Speaking to us today is our guest from Hewatele, and he will be talking about low pressure reservoir tank. His name is Mr. Michael Njuguna, and he is a biomedical engineer. This gentleman spends a better part of his life in finding engineering solutions to problems blocking the healthcare sector in low and middle income countries. I now invite Mr. Michael Njuguna to share us with what he has prepared. Over to you, Michael.
Thank you, Emmanuel, and the whole Oxygen Alliance team. I hope you can hear me.
Yes, I can hear you.
Thank you. So my name is Michael Njuguna, as we have all heard, and I work at Hewatele and also at CPHD as a biomedical engineer. And I'll be taking us through the low pressure reservoir system. And I'm hoping by the end of this session, we will have come to a point of knowledge concerning the system and the modules in the system. So let us start. So we will go through a number of sections in this session, and we will go through eight things. First of all, we want to describe and define what is a low pressure reservoir. Then we will go through the typical designs of a low pressure reservoir. Number 3, we will look at conventional setups of the same system. Number 4, we will look at the filling unit or the filling station. Number 5, we will go through the reservoir tank or the vessel. And thereafter, operations of the LPR. The number 7, troubleshooting. And number 8, maintenance. So what is a low pressure reservoir? It is a vessel designed to store oxygen at pressures below 20 bars via a concentrator and a filling unit, which is then used either as a primary oxygen source or as a backup solution. This is one way of how to describe a low pressure reservoir. And we have also noticed that its use cases is best appreciated in areas where power cuts or interruption of power is prevalent and hence utilized in between these eventualities. So the whole idea of a low pressure reservoir is to mitigate lack of oxygen in between adverse situations. Probably the concentrator is not working, or probably there is no power to run the concentrator. So it is in this desire to mitigate that this invention came about. So the typical design of this system has got 3 main components. Number 1, you must have an oxygen source, and we are using the oxygen concentrator as an oxygen source. There is the filling station, and there is the reservoir, which is now the low pressure reservoir. So these three components are connected via connecting tubes, as you can see on the slide. And we have a blue bubble on the screen, which shows how oxygen moves in this system. And you can see the blue bubble becomes a bigger bubble once it leaves the filling station. It goes to the filling station as a small bubble, then the bubble becomes big as it goes as it moves to the reservoir tank. And that, of course, we'll discuss as to what is exactly happening in that slide. So a conventional setups, as we have mentioned the previous slide, is that there is an oxygen concentrator, which is the oxygen source. We also have a filling station and a reservoir. In the extreme left part of the slide, you can see an oxygen concentrator in this setup. There is also a filling station, as you can see here. Then there is a reservoir at the bottom, which is not metallic. This is looks like a flexible bag. And once it's full, of course, then again, you are able to use it via an oxygen split, as you can see on this slide, on this part of the picture here. At the top part of the slide, top right, we have an oxygen reservoir, which is metallic, a cylindrical metallic reservoir, attached directly to an oxygen concentrator. And at this point, they have bypassed the filling station. And this is also one way of actually having a setup where there is no filling station, given that they have bypassed the reduction part of the concentrator where pressure is reduced for consumption. That part has been bypassed and attached directly to the reservoir, just to get the reservoir filled in the right operating pressures. So here at the bottom, we have got two types of LPR. This is a Biomedical LPR, which we will also be using in this session for just illustration purposes. We are not marketing any brand, but just for the sake of illustration purposes, we will use the Biomedical brand. So these are two reservoirs. One is big, of course. This has got more capacity in terms of storage, and this one has got less capacity in terms of storage. And this is the filling station, which is between these two vessels. On this other side, extreme right, bottom right, is another conventional setup: a concentrator, a reservoir. The filling station also has flow meters where you can use to administer the oxygen. And this setup here is not used as a backup, but as a primary source, the refilling station. And the reservoir, in this setup, the LPR is being used as a primary oxygen source. It is not just for backup, but for this design here, it is used for backup. So once you fill the reservoir, you set aside the reservoir. In the eventuality, the concentrator will not be working or there is no power. Yes. So I will not delve so much on the oxygen concentrator, because the Oxygen Alliance platform has done so much and a very good job as far as oxygen concentrators are concerned. And I would urge anyone who wants to know more about oxygen concentrators to visit their YouTube platform or their website, and you'll get nice content. So the filling station, as you can see, is in between the two components, the oxygen source and the reservoir tank. And the specifications of filling a reservoir tank from the oxygen source is that the concentrator should be at least capable of providing 10 liters per minute oxygen in terms of flow rate at the acceptable oxygen saturation, oxygen purity. So we are talking of 80% and above. 80% and above. So the filling station has got an inlet port, which this is where the oxygen concentrator is connected to the filling station via a tube. And the outlet port, this is where the reservoir is connected to the filling station. There is also a power button power switch, as you can see, and there is a cooling fan. And of course, on this other side, we have the reservoir tank. The filling station comes in various designs, but for the sake of this session, we'll use the Biomedical filling station, which looks like what we have on this slide. So why do we need a filling station in this setup? Why don't we just connect the oxygen concentrator directly to the reservoir tank? And the reason is that we need to be cognizant that a typical oxygen concentrator has an output pressure of 20 psi. And this is specific to air intensity. And this is not sufficient to fill a reservoir at its operating pressures. Hence, a filling station is incorporated in the design to facilitate for optimum filling via three main features that are found in the filling station. So the first feature, of course, because we are talking of pressure, there has to be a compressor inside the system. And why do we need a compressor? To increase pressure, of course, to the filling levels. Number two, we have a pressure switch, and this, of course, is specific to this brand. And the pressure switch turns off the device once the vessel is full. Number three, we have a flow controller, and this regulates flow intake to the compressor, so that now the compressor will not suck in, a vacuum. There has to be a flow control to make sure that that does not happen. So as I mentioned, this is the Biomedical oxygen reservoir filling station, and it has a very unique case, and the casing is quite robust. And at the top of the case, there is a handle feature. This is how you handle the filling station. This is how you carry it. And it is attached at the top part of the filling station, which is also, it can open up. And as you can see, there is a latch here and also a latch on this other side, just to make sure the top cover is well closed during operation of the device. As we had seen much earlier, the inlet port connected to the oxygen concentrator tubing. This is the inlet port indicated by the label in. And this other side, which has got a secure connection, is the outlet port, which is connected to the reservoir tubing. And at the bottom here, where we can see quite clearly, this red part here is a power button, the on and off switch. And of course, we have got cooling fan vents, and which we'll talk more about it in the next slides. So components of the filling station. So inside the casing, inside this casing, once you open this casing, this is what you will see inside. Pardon me for the visuals. We tried to get a better picture, but unfortunately we didn't. This was the best that we could get. And the components inside the filling station are highlighted, or rather we'll go through them based on the numbers that are pointing to those components. So number one, which is you could see the silver device over there, is the compressor, which is a 12-volt DC rating, and its output pressure is 10 bars. Number two here, as you can see, just adjacent to the compressor, is the pressure switch set at 5 bars. So in the event that the reservoir is full and the pressures get to 5 bars, it turns off the equipment. Hence, there is no pumping of air or other oxygen into the reservoir. And at that point, of course, you should also turn off your concentrator. Number three here is the flow controller, which we had mentioned earlier. It regulates the amount of flow rate that the compressor is to pull in and also push out into the reservoir. Number 4 is the battery. The battery drives the compressor. The compressor is not driven by power that is coming from the socket, but the battery is the driving energy of the compressor. Number 5 is the power supply unit, or rather the charging unit. This charging unit charges the battery charge. Number 6 is the cooling fan. The cooling fans are on both sides of the device, at the back and at the front, as we had seen in the previous slide. This is the cooling fan. There is also the same vent at the other side of the casing. And of course, as the name suggests, its purpose is to cool, of course, the internal environment of the filling station, so as the compressor should not overheat, and that would cause severe damage to the compressor. So to avoid that, we have got two cooling fans at the back and at the front. Number 7 is oxygen flashback arrestor. So while filling the reservoir tank, you don't want oxygen to go back to the system. So that feature right there is responsible for making sure that oxygen does not go back into the system once it has been received in the reservoir tank. So this is how our reservoir tank looks like. And of course, this is a biomedical tank, LPR. And you'd notice at the top, there is a pressure gauge, which enables the user to see how much pressure is inside the reservoir tank. And this reservoir tank is deemed to be full when the pressures are between 5 and 6 bars. The pressure gauge is graduated in bars. Just behind the pressure gauge is a pressure safety valve, which is preset at 8 bars. At this point here, we can see where one can connect patient cannula or patient mask with the outlet port, which is connected to a flow meter. The maximum flow rate is 5 liters per minute. And there is the flow meter knob, which you can use to adjust the flow rate that you're administering. At the bottom is the base, which has got the wheel casters. Because to easily move this device, rather this tank, which is a capacity of 100 liters, you'd at least need something to move, which are the wheels in this case here. So how do we operate? How does this system work? What are the operations? The number one, as we have mentioned earlier, you have to be very cognizant of the operations of an oxygen concentrator, because you're filling the reservoir tank from an oxygen source. And here we are not talking of a cylinder, because a cylinder is just but like another reservoir. So you want to use an oxygen source that can generate its own oxygen. So first of all, as you're using a concentrator, you need to be cognizant on the operations of a concentrator, which again, I would want to urge anyone who wants to know more about concentrators to visit the Oxygen Alliance platform for more information. So turn on the concentrator and remove the humidifier bottle or empty the bottle. Of course, you don't want moist oxygen to get into the system. If you have moist air getting into the reservoir tank, given that the reservoir tank is metallic in nature, you may now introduce corrosions inside the inner linings of the reservoir, and of course, then again, this will be introducing impurities in the long run to the oxygen that you shall be administering to the patient. So in the avoidance of that, make sure that when you're using a concentrator, you don't have a humidifying bottle attached to the device, or empty the bottle if you must use the bottle. Number 2, connect the inlet tubing at the concentrator outlet to the filling station inlet port. Once the purity indicator shows the purity levels are appropriate, it is at this point that you should attach the outlet tubing from the filling station to the reservoir inlet port and make sure that the reservoir flow meter is closed before turning on the filling station. So you don't want the flow meter at the reservoir to be open, because of course you will be filling the reservoir while oxygen is also escaping. So you will never achieve filling the reservoir. You will notice that the pressure gauge, which when the reservoir is empty, the pressure gauge is at 0. That pressure indicator will never rise to 5 because of course oxygen is escaping. So you need to make sure that the SAID are well checked before you turn on the filling station. So once you turn on the filling station, the cooling fan should not be obstructed. Of course, you would also be compromising the cooling effect that is required while being in operation. So once the reservoir tank is filled at 5 bars, the filling station will automatically switch off. In the process of time, of course, once the pressure at the reservoir is at 5 bars, the filling station will automatically switch off because of the pressure switch that we mentioned much earlier. And it is at this point that the concentrator should also be switched off. You don't want to pump in oxygen while the filling station is off. Of course, now because of buildup of pressure, you might cause tubings inside the filling station to start to pop off, and that is not what you want. And also this could also be the same effect inside the concentrator. So turn it off once the filling station is also switched off. And something that we should also note based on this brand is that it takes approximately 1 hour to fully charge the 100-liter reservoir tank. And it takes approximately 1 hour 40 minutes to fully deplete it at 5 liters per minute of use. So troubleshooting, and there are some common errors that you might witness while using LPR systems, and this is not only unique to this brand. Some of the common errors in the filling station are, as you can see on the slides, the device might not turn on. And of course, based on the general rule of thumb, when there is such an event, all the equipment that probably use power, of course, you need to look at the power source and check whether there is power at the main supply at the socket, probably by using a tester or a multimeter. And this is the possible cause, one of the possible causes. The solution would be to check the power socket and replace the power socket if the socket has a problem. If there is no power, of course, you can check the mains and make sure that the power is flowing to the outlet point where the device can be attached and work. Another possible cause is a faulty power supply unit. As we have mentioned, there is a charger that is secured at the top part of the filling station, and that charger turns on red once it's powered, and it shows also the status of the battery in terms of the charge level. So when it is not fully charged, the battery or rather the power supply would indicate as orange. Once it's fully charged, there is a green indicator light that you're able to see. So if the power supply unit or the charging unit is compromised in terms of its functionality, of course, this is also going to cause the device not to turn on because, of course, the battery has drained and it has got no power. So fix the power supply unit, and of course, if the battery is damaged, also change the battery. Another possible cause of the device not turning on is there is a pressure switch, as we had seen earlier. And if the pressure switch is faulty, then this could also cause the device not to turn on. So the solution to this is to replace the pressure switch. Another area is that running sound is noisy. The running sound, of course, here is the compressor. And could have a faulty pump valves. Replace the pump, or rather replace the valves, or you can also replace the pump, depending on the status of the pumps. Another possible cause is detached internal tubings. The internal tubings, once they are detached, you will experience very loud running sound. And the tubings themselves are, I would say, rubber in nature. They are malleable in nature, and that also works as a shock absorber, or rather sound absorber, sorry, and also dampens the sound of the operational sound. So check those things, check whether the internal tubings are detached. Of course, the solution is to reconnect any tubing that is detached. Another common error is overheating, and this could happen because, of course, the cooling fans, or one of the cooling fan is faulty. Fix or replace, that is the solution. Another possible cause of overheating could be the blocked cooling vents. Of course, we had mentioned much earlier that once you operate this device, make sure that the cooling vents are not obstructed. And of course, it could lead to overheating. Therefore, make sure that anything that would mitigate, or rather would compromise proper flow of air into the system is removed. We recommend at least 20 centimeters away from the wall, or anything that would obstruct the cooling fans is appropriate. So this is something that we should also consider. So of course, clean the vent if the vents are dusty. And this is part of the routine maintenance that we shall talk about in the next few slides. Another common error would be leakage. And tube connection points are loose. This is something that is common by reason of buildup of pressure in the system. You might end up experiencing some loss of pressure, and you should check how well connected the tubes are to the connecting points. Another possible cause would be valve failure. This also you should be able to check. And when it comes to valves, just replace the valve or the module that has the valves. And for tube connection points, make sure that the tubes are properly connected to mitigate that cause. Another common error is a noisy cooling fan. This, of course, would be because the propellers are not well aligned. And how to fix that is to either fix the propeller, or also fix the vents, the housing of the fan could also be getting into the way of the propeller. Just make sure that nothing is touching the propellers, because of course there will be great noise, rather much noise coming from the cooling fans due to the scraping of the propellers on probably the housing. You could also, depending on how the situation looks like, you could also replace the whole fan. So these are some of the things that you might see in this brand and in other brands that you can also apply in terms of mitigation. So troubleshooting for low pressure reservoir, as you have seen the tank, there is a pressure indicator at the top of the tank. And at times the pressure, not the pressure indicator, but the pressure gauge is at the top of the tank. So the pressure indicator at times might not move. And one of the possible causes of such a scenario is that the indicator is obstructed. That pointer is obstructed by the graduated plate. And this is also something that has been witnessed in oxygen regulators for cylinders. Oxygen cylinders regulators, where you find the graduation plate of the pressure gauge is kind of pressing towards the front, or rather leaning in a manner that is obstructing the indicator from moving up. So in the event that pressure, the indicator wants to move up because, of course, of the pressure that is inside the vessel, it gets obstructed, and you can't tell per se how much pressure is in the vessel, and that is one of the possible causes as to why the pressure gauge is not moving. of course, the solution is to align the pressure graduating plate. In the event that you have done what is needful, and still the indicator pointer is not moving in the pressure gauge, that is a faulty pressure gauge, and you need to replace it entirely. Another common error is a flow meter indicator not moving. And this, of course, would be because of a stuck indicator ball, or rather the bobbin is stuck at the bottom of the flow meter. And the solution is to open the flow meter and clean the flow meter column and also clean the indicator ball accordingly. So another common error is leakage. And leakage can be witnessed at the connecting point of the tube that is connected from the filling station all the way to the reservoir tank. That connection point can suffer from high pressure, and you might notice some leakages, or rather you might hear a hissing sound, or if you apply soapy water, you might see bubbles. So make sure you connect that pot, or rather that tube, quite well on the pot. Also, you could see some leakages at the safety valve. If the safety valve is faulty, you can notice some bubbling, or rather some hissing sound at the top. And this probably you notice when it is not close to the trigger pressure, which is 8 bars, and that means that you should replace the safety valve. So possible solutions for tubes not well connected: make sure that you ensure proper tube connections, and of course that will mitigate that in that sense. Mobility is compromised. Possible cause: the wheel casters are faulty. There are foreign things that have gotten into the wheel casters. Either remove those things, especially in the hospital. Sometimes you find hair, gets into the wheel turning points, and you need to remove some of those things. If in the event that is not possible, replacing the wheel caster is also another way of sorting that out. So maintenance of this device, the routine maintenance comes in daily routines. There is the weekly routine, and then there is a what we call the annual routine that is performed by the technical team. So for daily routine activities, this is done or rather performed by the clinician, or rather the one who's using, either the nurse, the doctor, whoever is using this device, probably even the patient, if it is placed in a home care setup where there is no nurse. This should be done by the user. And cleaning the surface of the LPR with 70% alcohol, part of the IPC protocols or other procedures. This is the infection prevention control procedures, should be done by the users. And this is on all surfaces of the system, be it the concentrator, be it the filling station, and be it the LPR. In the event that the LPR that is being used here is a backup solution where it has not been used for probably 2 weeks or 3 weeks because there is no event in which it has found use, it should be wiped or rather cleaned after every 1 week because it has not been used. But we recommend it should be cleaned in between patients and daily if it is a primary source kind of setup, which we have seen much earlier. Weekly routine is done by the technical team. This is, of course, checking the filling station, turn on the device and check whether the cooling fans are working, and remove any dust accumulating at the cooling chamber. This, of course, works, or rather is done on an LPR system that is used as a backup solution. Because, of course, it was put aside for another filling event. But in the event that you have an LPR system that is used as a primary source, where the filling station turns on and off intermittently based on the pressures inside the reservoir triggered by the pressure switch. The filling station should be checked on probably daily by also the user, the clinician, just to check whether there is dust accumulations on the cooling fans. And also they should also be in a position to look at the indicator lights that would show you the state of the internal battery and the power supply charging unit. Weekly for the reservoir tank, check whether the pressure gauge is working, okay? And make sure that the indicator should not go beyond 6 bars. And this is specific to this brand, the Biomedical one. Check proper functioning of the flow meter, as we had seen much earlier. That flow meter, that bobbin indicator should not be stuck at the bottom whenever you are trying to open to get some oxygen from the reservoir. So in the event that you notice that, make sure that, as we had mentioned earlier, clean the flow meter column and also the indicator. Annual routine done by the technical team. Perform the weekly procedures when you're doing a service. This device should be serviced annually and not in the period of 6 months. And this is specific to LPR systems that are used as backup solutions. For systems that are used as primary solutions based on the risk assessment and all that, we recommend 6 months period when it comes to servicing. But for LPRs that are used as backup solutions, like the one that we are looking at right now, annual routine maintenance in terms of servicing or other PPM should be done annually. So perform the weekly procedures, that is number one. Number two, check condition of the safety valve. You can use a PSV test kit, which are provided by instrumentation companies. Check for leakages. You can use soapy water on the connection points of the tubes. Check for bubbling. If you see bubbling, of course, that would mean that there is leakage at that point, and act accordingly. Check conditions of the compressor. Check condition of the compressor. Check whether it's overheating. Turn on the device for at least 5 minutes. Check for overheating and any form of noise that is not consistent to the normal operation, noise, and of course attend to any issues about the compressor accordingly. Perform pressure test and check the pressure switch condition. And you can use a manometer or a pressure gauge, and based on the manufacturer recommendations in terms of specifications, check whether those pressures are being met. Otherwise, if those pressures are not being achieved, of course, that would mean that there is a problem somewhere. Probably it would be the compressor is not delivering the pressures that are needed, or there is a leakage. And of course, you can be able to do the leakage test just to find out where you are losing pressures from. And of course, the last thing is to do the mobility performance, or check the mobility performance of the reservoir. It has got some wheel casters. Just check whether it is moving as it should. And then thereafter, of course, you can clean the surface of the whole system using 70% alcohol and return it back to service, or probably to the storage point. So basically, that is all about the LPR system. And I hope we have learned 1 or 2, 3 things based on what we have covered so far. So at this point, I want to thank you for your time, and hand it over back to Emmanuel.
Thank you so much, Michael, for the wonderful presentation. At this point in time, I will call for comments and questions. So we do it this way. You can either write in the chat the questions you have and the comments, or alternatively, you can raise your hand and they'll be able to call you, and then you can ask your question. Anyone with a question to Michael on the presentation? Okay, so we have a hand from Georgie Kwanga. May you please go ahead and speak?
Okay. I had like the requirement to use this low pressure reservoir is in terms of having a concentrator 10 liters per minute. Is it possible to have two concentrators that are 5 liters per minute each, and you combine them so that you use it with the one low pressure reservoir?
All right, Michael, did you get that?
Yes, I heard George. Thank you, George, for that question. Of course, our desire is that the filling station should get flow rates from any oxygen source, especially concentrators, at 10 liters per minute. So your approach is more of a creative way to make sure that the reservoir tank gets the adequate amount of oxygen. So yes, I must say that that is also one way you can achieve that.
Okay, George, does that answer your question?
Yeah, that's clear.
All right, thank you. So we have another question in the chat from Kevin Saidi, and he says, is the DC compressor serviceable?
Yes, the DC compressor, some minor, I would say, service that you do is check given that it is a reciprocating pump kind of mechanism, you can check the piston cover, or rather the piston head. Check for any wears on the sleeves of the piston. And that, of course, you're doing it by checking, first of all, the pressures before you get to the compressor. And I would say some minor touches on the DC compressor, but we don't recommend per se servicing the compressor per se, the DC compressor.
Okay, so thank you, George. Kevin, you let us know if that answers your question. We have a couple of questions in the chat. I'll read out to you. We have another question from Chimwemwe TS, and he asks to say, do you have a pressure regulator that's between the tank and the flow meter?
There is no pressure regulator per se, but the feature there between the tank and the filling station is the pressure switch, which cuts off pressures at 5 bars.
All right. We also have another question, and it says, how does the PSV kit work?
So the PSV kit works by, you have to have, the kit comes with a block, and the block, on one part of the block, you connect the pressure, or rather the safety valve. There is a place where you connect the safety valve. And then on the other part of the block, on the other side of the block, you connect the pressure safety valve test module. There is a small module, looks like an oxygen analyzer kind of module, depending on the design of the manufacturer. And at the extreme end of that block, there is an inlet port where you connect a tube that you'll be feeding the block with pressure. So once you pressurize that block, you can be able to see how much pressure gets into the instrumentation device, the PSV tester, and also what is getting at the safety valve that you have attached on that block. So once the pressure builds up to where the safety valve is triggered, probably at 5 bars or 8 bars, the instrumentation device that we have connected on the other side of the block will get to analyze when the safety valve was triggered. and also we can be able to see when there was the crack and also the receipt of the safety valve. So you can get this analysis on a computer if the instrumentation system is connected to a computer and generate a report. I hope that answers your question.
Remains my hope too, and I hope Good Luck will give us feedback on that.
Okay.
Are there any questions?
I think I should have probably incorporated a picture on that one. But probably next time I might do that.
Yes, probably. Okay.
Yeah.
And you can alternatively just share with us, and then we can compile it for our YouTube channel and the Facebook page.
Okay.
But before we wrap it up, we have another question in the chat, and it says, it's from Grace Banali. Can we use the oxygenated air in the tank while the whole system is working?
Yes, you can use the air in the tank. And of course, I had mentioned earlier, there is two ways how you could use the LPR system. There's one that is designed as a primary source where you are using air directly from the tank while, the concentrator is not used to attach to a patient, but it is attached permanently to serve the reservoir tank. That is one way you can use it. There is also another way you can use it also as a backup solution. And also as a backup solution, you can use it to the patient, or rather with the patient, but you have to make sure that the tank is at least half full, so that now you can have consistent flow of oxygen rather than having oxygen deplete when using it to the patient. So the answer is yes, but consider what I've mentioned for proper usage.
Okay, I hope, Grace, that answers your question. And we have another question from Kelvin Said again, asking to say, how long does the battery last, and can charging occur simultaneously with use?
Yes, the charging can occur simultaneously with use, because then again we had mentioned that the battery is the driving power for the compressor. So the power supply unit in this instance, it's not to serve as, it's not to serve the compressor with any form of power, but to charge the battery. So how long it lasts? It can last as long as there is power, because it is continuously charging while also operating the compressor.
All right. So I hope, Kelvin, that answers your question. If there is no one who wishes to speak or comment or ask a question on this, okay, so we have a hand from Mwawi Lungu, and we have a couple of questions coming up. We still have some 8 minutes, so let's take these ones. Mwawi, could you go first?
Yeah, thank you, Emmanuel. So it's interesting that you are working with a DC motor. We've also been trying to play around with a DC motor and see how we can incorporate it in some of the projects we are working with. So are you doing any speed control on the motor, Michael, or it's just at maximum speed when it's filling the tank?
We are not doing any speed control. It's just at its maximum speed, based, of course, of the amount of energy that we are serving the motor.
I see. So was that is it something that you considered to include? Because I think it might also come with its benefits, because you wouldn't want to be running it at the same speed when you are nearing the max pressure of the tank.
Okay, it's something that we might consider. Thank you for that comment. I think I'll have to take it up with the whole team and probably see what we can get out of that, and probably get back to you.
All right. So
and probably more, what would we achieve by doing that, if I may ask?
Sorry, say again. I missed the last part.
You mentioned that it would be beneficial to have some form of speed control on the DC. So I'm just asking, what would we achieve by doing that, if I may ask?
I think it's more just an issue of energy saving, because you probably might not need to run it at the same rate when the tank is almost full.
Okay.
Okay, so we have the hand from Mikwanga, but before that, we had a question in the chat from Grace Banali, and it says, why is there no filter after the oxygen concentrator? Can't the air be contaminated? So after this one, then we can take a question from George.
So as we have seen, the system is not open, it's a closed system, and the air, or rather oxygen, that is getting to the reservoir is passing through the three-stage filtration system of an oxygen concentrator. Of course, there is the gross filter, the internal filter, and of course the microbial filter. And that is the air that is taken, or rather is received in the reservoir. In this instance, the filling stations do not come in a manner where they can receive oxygen or air outside the oxygen concentrator system. So there is no filtration. The filtration is done at the oxygen concentrator, or at the oxygen source site. So I hope that answers your question. So we as we can see, the reservoir is not receiving oxygen from any other source, or rather outside the concentrator. So whatever we are getting from the oxygen concentrator is what is being received in the reservoir. So there is no need of any other form of filtration, given that the system is closed.
Okay, so George, would you unmute yourself and speak?
All right, Michael, I wanted to take you back to where you were presenting on the reservoir tank. You presented, I think it was second slide. There were some of the reservoir tanks. So I wasn't clear. So the other one, I think, in terms of the material of the reservoir tank, in terms of the design, can you go back maybe to the slides? Just explain. I just want to ask something on the material that is used on the design of the tanks.
Okay, so whilst Michael is trying to pull that up, just a reminder that you can also type your email address in the chat so that we can stay in touch and we constantly remind you of upcoming topics. Over to you, Michael.
Yeah,
this
here.
slide?
Yes, this one in black. Can you explain about that one? I think I missed something on this.
So on this design, or rather this conventional setup, this is a prior to design, and I don't have the rights to present it, because this is not a design that we have worked with, but it is a design that has got a very unique reservoir, just to mention. The reservoir here is not metallic. It is a bag that is filled with oxygen based on the filling station, and also there is a tank at the top part of this setup. There is a small water source that is also used in terms of building up the pressure and in the reservoir. Of course, there is an oxygen concentrator, as you can see, the air safe oxygen concentrator at the back over there. And there is a filling station here. Then there is the oxygen flow splitter based on the oxygen that has been received from the reservoir into this bag. And this is where you connect your patient cannulas.
All right, thank you.
Okay, so we would have wound up at this point, but we have two questions in the chat. So I'd like you, Michael, to take this quickly, and then we can wind up. We are running short of time. We have one question that says, what is the user feedback like on this system? and what is the estimated lifespan of the system? This is from Kelvin Saidi, and Sharon Ngozo says, which direction is the fan on the filling station blowing to? So after this question, then we can call it a day.
Okay. So the user feedback on this system is that it is best appreciated by the users, especially in areas where power cuts and power interruptions are prevalent. Especially here in Kenya, I would say the western parts of Kenya, where the weather it's very wet, that part of Kenya, and very many storms and very many episodes of rainy seasons and all that. And in those moments, power cuts and power losses are quite prevalent. And it is in those events that users have really appreciated the system, because when there is no power, the concentrators can't be used, but the facilities that have got low pressure reservoirs have oxygen in between those power events. And they really liked the device. There was another brand that we tried to bring in here in Kenya, but it didn't work because it wasn't robust. But for the Biomedical one, the uptake, or rather there is positive vibe as far as that the system is concerned.
Okay, and the last one, which direction the fan blows to on the filling station?
So we have got the fan that is at the front of at the front part of the filling station, and then there is another fan at the back side of the filling station. So one blows out and one blows in, so as to make sure that there is circulation of air inside the filling station.
All right, thank you very much, Michael, and many thanks to Hewatele for accepting to share with us this immense knowledge, which is very important in low and middle income countries. Just a reminder, we stream these talks on Facebook, so if you have questions, you can as well leave the questions in the comment box on that site, or write to us at info@oxygenalliance.org. Would be available to take those questions and come back to you, or at least refer to Michael and then give you feedback. These calls come your way every second and fourth Thursday of each month. We also send email invites, as I already said, so you can share us your emails. The next meeting will be on the 13th of July, and please send us a list of topics that you think would be interesting to cover, and we'll be at your service to provide information on the same. Reaching this far, I'd like to thank everyone that joined the call today, and wish you a successful ending of the week. Thank you very much.
Thank you. Bye.
Bye-bye.
Thank you.
Thanks, Michael. A wonderful presentation. Bye.
Thank you very much.